Okay, so I'd like to start by talking about why we should study psychology as a science. So you might hear about a psychology study on the news and think, gosh, that's silly. We just spent taxpayer money to find out something, we knew already. Something that seems like common sense, something that's obvious. And we think that we know everything or most everything about human behavior, that we're experts on human behavior because, of course, we are humans, and we do know a lot, but we have this bias. And so the bias is essentially that when we hear stuff, we think that we already knew it about human nature. So let me give you an example. So let's say you hear on the news about a research study that found, so psychologists have found that separation weakens romantic attraction. Okay, and so you might think, sure, we knew that already. We have a saying for that. We say out of sight, out of mind, right? But what if you heard on the news the results of a study where psychologists have found that separation strengthens romantic attraction? If you heard that, you would also think that you already knew it, right? Because we have a saying for that as well, which is absence makes the heart grow fonder. So we call this problem the hindsight bias. And so this is the tendency to believe after you learn an outcome that you knew it all along, that you already knew that finding, okay, that outcome. So we have this bias called the hindsight bias. It affects how we interpret results that we hear about psychology studies and things like that. So this is why it's really important to study psychology as a science. So on the next slide, I'm going to go through a bunch of actually, I believe 10 true-false statements, and so we'll just talk about each of them. So the first one, so most people only use about 10% of their brain. This is false. This is something that has just gotten loose in popular media, and no. You, in fact, use all of your brain, and at any given time, you're using between 25% to 40% probably right now, just sitting listening to this. Okay, if you were doing something more active both cognitively and physically, you would probably be using 60-70% of your brain, okay, something like that, like doing a difficult like dance choreography or something where you had to really think, or playing a sport that was really complicated and really active. Okay, you'd be up around that percent at one time. Okay, but we use all of it, and so neuroscientists aren't really sure how this idea about the 10% got loose. They think that maybe we use about 10% of our brain for basic sensory motor stuff, right? So our five senses and our motor movements is about 10% of our brain. And so that's maybe where people got that idea. But no, absolutely no. I mean, wouldn't that be sad if we only used 10%? And wouldn't you hear more about it in the news, like how to harness the other 90% of our brain? So no, we use all of it. So number 2, most brain activity stops during sleep. No, that's false. So your brain starts working, right? All of your neurons are working and firing long before you're born, and they keep working until about 5 minutes after you've died. Actually, they're still working. So no, right? So absolutely, your brain is working. Your brain activity is still going while you're sleeping. And in fact, we've learned a lot about different stages of sleep and about dreaming and things like that by monitoring and recording people's brain activity while they're sleeping. And so we'll talk more about that in the chapter on consciousness. Number 3, police departments often use psychics to help solve crimes. False in terms of the often part. I mean, every once in a while, there'll be, someone who, if there's a cold case for 20 years or 30 years and they've got, no other ideas, sometimes they'll do something like that. And if you've ever seen there have been TV shows that feature, these sort of cold cases, and they have psychics come in and they solve the case, and you see, and it's very convincing. And so the scientific explanation for this, and whatever, I'm open-minded about all things. There's a lot of things we don't understand in the world, and in science. There's a lot of things that science doesn't have an explanation for. But the scientific explanation for this sort of thing is something along the lines of people who talk a lot are sometimes right. So the thinking is, when the psychic says, the body is buried, in the woods over there, the body is buried, or the body is underneath this, patio concrete or whatever, and then at some point the body is under the patio concrete, and then we're all blown away, right? And so that's what makes it onto the onto the TV show. But anyway, so not so much. Okay. And then next we have number 4, punishment is the most effective way to permanently change behavior. So that's also false. The most effective way to permanently change behavior is to change people's motivation, and punishment is not the best way to do that. Punishment is necessary sometimes, but it's not actually the most effective way to change behavior, and this might be counterintuitive, but we'll talk a lot about this in the chapter on learning. So just think about, you can think about kids and kids' behavior. When people use mostly punishment, what kids do is they learn who they can get away with what stuff in front of, right? Or they just sort of do the behavior when you're not looking. And we do this as adults. So just think about your own driving behavior, okay? I'm sure you're all very safe drivers, as am I. But, do I always do 65, or under on the highway? No. Okay. I drive very safely, but I drive with the flow of traffic. Okay. I'm not, busy cutting people off and speeding around, but, but I don't always, right. But when I do, if I see a police car in my rearview mirror, I go, right. You start to go to the speed limit. Okay. Same thing with, stopping at stop signs, and, actually, when you stop at a stop sign, you're actually supposed to count to 3, right? You're supposed to stop and then count 1001, 1002, 1003 before you go. Really, no one does that unless there is a policeman there watching you, okay? So we tend to use our own judgment, right, when the person who could punish us is not there, is not looking. And so if you want to permanently change behavior, you have to change people's motivation. So we'll talk more about that. And then number 5, eyewitness testimony is often unreliable. This is true. Eyewitness testimony is often unreliable. And this is because of the nature of our memory, essentially. So our memories, we tend to remember just little bits and pieces of things, and especially if you're in some very stressful situation where you might be an eyewitness to a crime or something, you will likely remember how you felt in the moment and lose a lot of the details because the situation was so stressful. And just even everyday memory tends to be really malleable and changeable, and we tend to remember just the gist of things rather than exactly what happened. And we'll talk a lot more about eyewitness testimony when we get to the chapter on memory. Number 6, polygraph or lie detector tests can accurately reveal if a person is lying. So what the polygraph tests are actually measuring is just what we call arousal in the body. And so just general arousal in the body. So this can be you're scared, you're nervous, you're guilty. Okay. Lots of different things can cause physiological arousal in the body, and that's all it's measuring. And so we interpret that as feeling guilty, but it could just be that the person being questioned is incredibly nervous about the test. So what can happen with polygraph tests is that innocent people can look guilty because they're so nervous about the process, and guilty people can look innocent if they are, psychopaths, and they don't really care about the questioning and about the consequences and about what they did. If they're not feeling guilty at all and they're just, numb, then they'll pass. Okay. So yes, so polygraph tests can catch some normal people who've committed a crime who feel legitimately guilty. Okay. But they can also make innocent people look guilty and guilty people look innocent. So they're not great, okay, at actually detecting lying specifically. They really just detect arousal in the body, and then we make inferences from that. And then number 7, people with schizophrenia have 2 or more distinct personalities. False. Okay, so schizophrenia is separate from the disorder where you have multiple personalities. That's called dissociative identity disorder now. It used to be called multiple personality disorder. Schizophrenia is totally different from this. So schizo means break, and so people with schizophrenia, essentially, they just have one personality, but there's a break with reality. Okay, that's what that means. Number 8, males are naturally more aggressive than females. That is probably false, and it entirely revolves around how you define aggression. So if you define aggression solely in terms of physical aggression, then yes, then that's probably true in most circumstances. But if you broaden your definition of aggression in any way to include things like social, emotional aggression, then oh my goodness, no. Okay, then that would be false. Okay, we're pretty equal for sure. Number 9, our past experiences are all recorded exactly in memory. So no, so that's false. Similar to what we talked about in terms of eyewitness testimony being unreliable, same thing here. So we don't just record, it seems like we do, but we don't just record all of our experiences exactly in memory. That's not how memory works. As I said, when we were talking about eyewitness testimony, we tend to, even in class, in everything we do, we just remember the gist, little bits of information, and then when we remember things later, when you want to tell someone about your day or something that happened to you, you remember the little nuggets, the little bits of information, and then the rest of it you make up. Okay, I know that that's hard to believe, but we'll talk a lot more about this in the chapter on memory, and actually I'll get the majority of you to create a false memory, which will be fun. Okay, and then the last one, opposites attract. This is mostly false, especially in terms of like a life partner, and we do tend to be most attracted to people who are most like us, and also who like us, right? And so, yeah, and there might be something about them that's different from you that you're attracted to, but the majority of their personality would be pretty similar to you. Okay, so hopefully there were enough of those sort of common beliefs there in those 10 true false statements that you were wrong about, that have made you open to the fact that psychology should be studied as a science. Okay, that we really need to do that. So I want to go through next the scientific method, which I'm assuming all of you would be familiar with at this point, having gone through any science class in high school, right? This is the way all sciences operate, okay, using the scientific method. So the first, and so this, we'll talk about all of these steps using an example. And so step 1 in the scientific method is reviewing the literature. And so this just means essentially you come up with some area that you're really interested in, maybe a specific question, and now you're curious to see what people have done in that area. And so you read all the studies that have been published, maybe some books, and you find out what people have done before. Have people answered the question that you're interested in? And then If they have not, then you start to become a little more specific in terms of the experiment you'd like to do. Okay, so let's say you're interested in, how much saliva we produce. And in our mouths, right, in response to either savory foods versus sweet foods. Okay, so that's your question. So you want to find out, because no one's done it before, let's say, so you want to know how much saliva we make in response to savory versus sweet foods. So this might be, right, the savory might be like pizza, right, freshly baked pizza, and the sweet food might be freshly baked cookies. Okay, so here's where we're getting into the, right, step 2, okay, developing a testable hypothesis, and then we can actually design the study. Okay, so what you want to do is actually think really critically about how you're going to measure things. So for example, you probably wouldn't, expose someone to, let's say, 30 seconds or a minute of freshly baked, I don't know, pizza, lasagna, whatever, for your savory option, and then just ask them, like on a scale of 1 to 10, how much saliva have you got in your mouth? Okay. People wouldn't be very good at estimating that, right? On a scale of 1 to 10. When have you had to assess your saliva before? Probably never. So better would be, you might do something like take 2 cotton balls, weigh them. They weigh a little something. Then you put 1 cotton ball in each side of their mouth, like by their cheek, right in their lower part of their mouth, and then you expose them to, let's say 30 seconds of freshly baked lasagna, and then you take the cotton balls out and then you weigh them. Okay, and so that would be a measure of saliva. It's gross. And then you do it again with freshly baked cookies, and then you would probably counterbalance. So half of your subjects would get the savory item first, and then half of your subjects would get the sweet food first, like the cookies. Okay. So very good. So you collect your data, okay, and then in our little circle here, and then you analyze the data. Maybe based on some previous studies, you thought it was going to be the pizza or the lasagna, right, the savory item that was going to produce the most saliva. Were you right? Were you wrong? Okay, and then you publish your results. Okay, and then you essentially you're getting scientific review when you publish them, right? So in order to publish something, it has to be reviewed by several other scientists in the field. Maybe you build a theory, and then the cycle continues. Okay, so essentially this would be, as a scientist, your life. So what you would be doing is then, right, building a theory about whatever, saliva, okay, production. And then you go back and you see, okay, what were people doing in my field during this time while I was doing this study? What have other people published? And then you come up with another study, and then you design it and collect the data, and then blah, blah, blah. Okay. So in science, these are the steps that you go through. And this corresponds to what, if you've ever done labs in high school or college. So this would be the introduction, the method, the results, the discussion. Okay, that sort of summarizes the scientific method. Okay, so next I want to talk about the research methods that we use in psychology, and there will be several. So the first kind of research is called descriptive research. And so in descriptive research, there are a couple kinds, and you're essentially just describing what you're seeing or learning about a situation. And so the first example of descriptive research is what we call a case study. And so with case studies, this is when you study one person in great depth. And sometimes you could do a report, you can publish a report of like several case studies of people who are similar, but for the most part, a case study is typically one person that you study in great depth. And so usually you find out everything about them. Usually it's some sort of, often it's a medical condition that's really rare. So you do case studies only in situations where the person has some sort of condition that is very rare, and you may never come across another person with that condition in your entire career, in your clinical practice. And so you would do a case study on them because they are so rare. If you came across lots of them, you would just do an experiment. Okay. And so you do the case study because typically their situation is rare. Also, you see a lot of case studies done with people who have brain damage because no one has the same exact brain damage as another person. Okay, it's always a little bit different than the next person. And so there's a lot of case studies done in neuropsychology. And so the problem is with case studies that the information that you learn doesn't always generalize to all people who have that condition or that disorder or that syndrome, or it might not generalize to other people who have similar areas of their brain that are damaged. So because you only have one person, and so what you learn about that one person may or may not be true about all people who have a similar condition. And so the idea is you might be writing down and publishing things that are just sort of special and quirky about that one person. And it's not true of the disorder. It's just true about that person. And with only one person, you don't know. Okay, so that's the big problem with case studies. But the upside is, especially in neuropsychology, there are huge databases where people just upload their case study, and then, once you have 40, 50, 60 case studies on similar brain damage or the same condition, the same syndrome, then that becomes much more powerful. Okay, but alone, that's the problem with a single case study, is that the information may or may not generalize to other people. And then the next kind of descriptive research is the survey or self-report. And so this is when we study thousands of people with only like a little questionnaire. Okay, so this is essentially the opposite of a case study. So a case study is you study one person in great depth, and with surveys, you study lots of people with not much depth at all. Okay, you only ask them a few questions typically. Okay, and so there are a number of problems with surveys, and so we'll go through that for a minute. So I wanted to talk about how surveys can be misleading, and so the first is wording effects, and so what I mean here is the way in which a question is asked on the survey can change or affect how people will answer. And I know that this feels like it can't be true, and you probably think, no, I have my own opinions, and it doesn't matter how someone asks me the question, I will answer honestly, and the way that they word it isn't going to change my opinion or change my answer. But people who write surveys are very clever. It actually costs a lot of money to write a good survey, and typically you have to think about that. So if it costs a lot of money to make a good one, or to make one in general, people have, an agenda. People have an incentive, and they typically want you to answer in a particular way, right? So if they've paid a lot of money for a questionnaire or a survey to be written, then they want you to answer in a certain way. They're motivated. And so let me just give you an example. So people are more likely to approve, quote, not allowing things than like censoring them or forbidding them. So in a recent national survey, only 27% of Americans approved of, quote, government censorship of media, sex, and violence, but 66% approved of more restrictions on what is shown on TV. Okay, so I'll say that again. So 27% of Americans approved of government censorship of media, sex, and violence. 66% approved of more restrictions on what is shown on TV. That's essentially the same thing, but when you say government censorship, all of us are like, oh, right? Our backs go up like, no way, there's no censorship. This is America. Okay, right? But then we do, the majority of us, 66% of us think like, okay, but if you call it more restrictions, we're fine with that. Okay. But the meaning is the same. So just, try and use this information to question things that you hear on the news, question the results that you hear, because it probably is fairly skewed, especially if they are, reporting on the results of a survey. It would be good to know what the actual questions were and who paid for the survey to be done. So the other problem, the other way that surveys can be misleading is through what we call sampling error. And so this is essentially when people in your study don't represent the population. So in mass surveys, typically what they do is either, this could be like through phone calls where they just are calling, just every number in this big bank of phone numbers, or they're doing a mailing or an email, mailing. And typically in surveys like that, where you have to sort of self-select, where you decide you're going to respond, only 2, maybe 3% of people ever respond. And the problem is, and that's good. Like if 4% or 5% responded, people would be really happy. That would be a great response rate. Isn't that wild? So yeah, so the problem is that typically when we get the results of a survey, in the way that most people run surveys, there's this huge problem with sampling error. So the people who've responded don't at all represent the population. So let me go through an example with you. So let's say you wanted to know what everyone at City College thought about the food options on campus. Okay, so you send out an email to every student and every staff member and you ask them. So what would happen is that only about 2 to 4% of people would respond, right? Because we're busy, we have no personal interest really in responding. And so the few people who do respond because they have some reason why they want to. So they just got food poisoning in the cafeteria, or their uncle owns one of the food trucks, or they just found little bits of aluminum foil in their soup, or whatever. So they have a reason. It matters to them. But are those people who found the aluminum foil or whose uncle owns the food truck, are they representative of all of us? No, they're not. Right? I didn't get food poisoning. My uncle doesn't own a food truck. That's not my voice. It's their voice. So the small number of people who respond are not actually representative of all of us. And so what we want to know is what all of us think, right? That's why you want to do the survey in the first place. And so by getting a response rate of 2, 3, 4% from people who are, motivated in some specific way, they don't represent us. So what you could do is randomly sample. And then you do get people in your survey who do actually represent the whole population. So the population, I didn't say, so the population in my example would be everyone at City College. And we obviously can't ask everyone at City College because that would take forever, because there's 20,000 of us or more. Right, so to randomly sample, what this would look like, you could get a couple people, stand at a few different places on campus with a page of questions, like one side of a sheet of paper and a clipboard and a small amount of cash to pay people. And then you could count as people walk by you, and then every 100th person who passes you, you could have a little clicker where you just click right as people pass you, so you don't have to keep the number in your head, right? And then when the 100th person passes you, you walk up to them and ask them if they'd be willing to answer a few questions about food on campus in exchange for, you pick an amount, so let's say $5. You have to pick an amount that 80-90% of people are going to go for. Okay, they're going to say, sure, I'll answer your 10, 12 questions for $5, right? $5 could get you lunch, on campus. And so you have to pick an amount that most people will go for. And then you're done. Now you have a random sample. You can ask actually very few people, because they were randomly sampled. They didn't self-select. They didn't choose, right, to answer. You chose them. It'll be a very accurate reflection of what all of us think about the food. This is actually how they do, for example, how they know in elections, right? How they know how things are going, right? What all of us think about different candidates. They ask remarkably few people, but they do it really, really well, okay? They sample in such a way, okay, that they can actually accurately reflect the population that they're interested in. And then the third kind of descriptive research is what we call naturalistic observation. And this is when we study the behavior of humans or non-human animals in natural surroundings. And so this could be, if you're interested in, I don't know, in a project where you'd like to know more about interactions between caregivers and their kids. So you might try and observe people in like a park or something, like in a playground area, but you have to be covert about it so they can't know that they're being watched. Once people know that they're being watched, they behave differently. Okay, same thing with animals, same thing. So if you're interested in studying, I don't know, gorillas or chimpanzees in the wild, people who do that actually have to live near them, in the jungle for like 6 months so that the animals get used to them being there, and then they can start collecting data. Okay. But before then, the animals are acting differently because there are these weird people there. Okay, right? So same thing with humans. If we know someone's watching us, we aren't acting naturally. Okay, so naturalistic observation, for this to work, it actually has to be where people and animals either aren't aware, or you've been doing it for so long, right, in the case of the animals, where they begin to act naturally. They start to ignore you because they realize you're not going away. And so naturalistic observation, it doesn't explain behavior, it just describes it. Just the way these other two, just the way the case study does and the way the survey does. Okay. Okay, so the next research method I want to talk about is correlation. So we talked about descriptive research first, and there were 3 examples. And so the second is correlation. So correlation is probably the most important topic from today's lecture. We're also going to talk about experiments, which is really important. But one of the most common errors that people make is to infer causation from correlation. So when they hear that 2 things are correlated, they assume that one thing causes another. And it does not at all. Okay, it might, but when you just have correlational data, it doesn't tell you that. So we're going to spend a bit of time going through this. So a correlation is a relationship between 2 variables. When 2 things are correlated, they predict each other and they vary together. Correlation tells us nothing about cause, whether one thing causes the other, right? And in order to investigate cause and effect, you need to do an experiment. Okay, so I want to go through some examples of this. Okay, so first I'll give you an example to let you know, what I mean by correlation telling us nothing about cause and effect, about whether or not one thing causes the other. So among men, length of marriage correlates positively with hair loss. Okay. So we usually think, when we hear that, you think like, oh, wow, okay. So it's, they're getting, if they've been married a long time, maybe they're getting nagged a lot. Okay. That causes them to lose their hair. Okay. We come up with all these ideas and we assume that being married a long time causes men to lose their hair. Okay. Which is silly. Right? But our brains jump to conclusions like that. But really, why are people who have been married a long time, why are men who've been married a long time losing their hair? Because they're old. Yes? Okay, so it's a third thing. Okay? It's age, right? That's actually having more to do with hair loss than the amount of time you've actually been married. Okay? So let's go through some other examples. So let's say there's a correlation between low self-esteem and depression. Okay. It could be that low self-esteem causes depression. It could be that depression causes low self-esteem. We don't know. Okay. Or it could be that some third thing is actually causing both of them. So it could be some distressing life events or a biological predisposition or 100 other things could be causing both of these. Okay. So just finding a correlation between the two of them says absolutely nothing about whether or not one causes the other. And very often it's not causal. Okay, they're just sort of tracking together, but one doesn't cause the other. It's usually some other thing or things are causing them, and they just happen to go together, right? So what we just said was, right, so they predict each other and vary together. That's it, right? So, so I want to go through how we represent correlation, okay? And there's actually what we call, which I'll describe in a minute, we have what we call a positive correlation or a negative correlation, and then we'll talk about how we represent those. So the correlation coefficient is just a lowercase r, that's how we show it. And then the plus or minus, the positive or negative here, indicates the direction of the relationship. We'll go through that. We'll go through several examples. And then the number itself here can range from 0 to 1. That's all, 0 to 1. And that tells you how strong the relationship is. Okay, so 0 means there's absolutely no relationship, and 1 means there's a perfect relationship. And so we'll go through what that means. So usually what I would do in class at this point, because I like to show you guys where, how to graph things, where the points come from and all of that. So before I start showing you lines on graphs and things, I like to go through an example using data from the class, just so you can see how it works. So usually what I do is height and shoe size. And so I'll plot something like this. And typically before I even plot this, I'll ask what the range is in the room, okay, for shoe size and for height. So I'll usually ask for volunteers. I don't make everyone do it, okay. And I do understand completely that shoe sizes are different for men and women. However, so in a perfect world, I would have two graphs, one for women's shoe sizes and one for men's shoe sizes, but it works. This is such a strong correlation that it doesn't matter, okay. So, and I also don't want to make lots of people give me their height and shoe size if they're not comfortable doing that. So it's a volunteer basis situation. And so this is sort of like the range. Sometimes people have size 4 shoes, but yeah. So this is the shoe size range typically, and then this is the height range typically. I included some very, very options for very tall people, because it's not uncommon for me to have several basketball players in class. So we do get up in this range for sure. So then what we would do is start plotting points, and usually it's something like this. You could, there are outliers around here, but usually it's something like this when we go plotting points. Okay, so you can see, so like for example, so this person is 5'2" and has shoe size of 6, okay, and then like this person has a shoe size of 9 and is 5'4", and then you also have someone with a shoe size of size 9 who's 5'8", and then someone else who has a shoe size of size 9 who's who's 5'10", okay, and so you can see, right, you can follow how all of these, right, points are plotted. So here is size 12, 6 feet. Okay, here's size 11, 6 feet. Okay, size 10, 6 feet. Okay, like that. Okay, so we plot all the points. Okay, and then usually what I do is I sort of circle, okay, around. I do this sort of this circle that shows you, that should sort of capture all of the possible points. Okay, you might be an outlier here, and if you were, I would have circled around your point. Okay, and so this is an example of what we call a positive correlation. So a positive correlation just means as one variable increases, the other one also increases. Okay, so height here is associated with shoe size. Generally speaking, the taller you are, the bigger your shoe size. It's sort of a physics situation, right? If you're taller, you need bigger feet so you don't fall over, okay? Things like that. Okay, so a positive correlation, as one variable increases, the other one also increases, okay? So then we can talk about the opposite. We can talk about negative correlation. And so here I won't ask you for your information, right? So here I'm plotting accident rate and hours of training. So if you can imagine, I don't know, someone who's training in a simulator to learn how to fly a helicopter, let's say, okay? And so if you have 0 hours of training, I would imagine you're going to make the most accidents ever, right? When you have literally no training. So your first moments in the simulator, you're going to make the most accidents you're ever going to make. I hope you're, after training, you're not going to make more accidents, right? And then as your hours of training increase, okay, your accident rate should be decreasing, right? So that once you've had 100 hours of training, your accident rate should be 0. Okay, and so that's what we call a negative correlation. So a negative correlation is as one variable increases, the other variable decreases. And so in our example here, as hours of training increase, number of accidents decrease. Okay, so just some more examples of this. So here, this is what a perfect positive correlation would look like. And then I just drew a perfect negative correlation for you in the previous slide. And then here, this is what no relationship would look like. Just so you know, in human behavior, you're never going to get a perfect anything. You're never going to get a perfect positive correlation or a perfect negative correlation because we're too variable as humans. So anything you're going to measure about human is too variable to get a perfect correlation in either direction. And then some more examples. So here you have years of education and salary. Okay, there tends to be a positive correlation between your years of education and how much you make. It's not a perfect correlation. Okay, you could spend a lot of time in school and not be having a huge salary. Teaching is one of those fields, but you know, it's a positive correlation for sure. And then there tends to be a negative correlation between exam scores and class absences. So the more you are absent, the higher the absences, the lower the exam scores. Okay, that does tend to be true. And then there's a 0 correlation between intelligence and shoe size. Okay, so that's not related, right? And then another example, so if you learn that there is a correlation only between stress and cancer, okay, now we know that you know, we've done experiments to show, okay, but let's say we only have a correlation, okay, so stress could lead to cancer, sure. Cancer could lead to stress, sure, right? I would imagine. Yes. Okay. And then also, right, if you only have correlational data, right, there's a bunch of other known and unknown factors like exercise and diet and things in the environment, right, that could be affecting, right, causing both stress and cancer, right? So that there's that idea that there are other factors when you have a correlation. It's not very often, it's not just a simple thing where one causes the other. Usually there are other factors. Having said that, there are some studies that have been done indicating that stress is not great in terms of your, you know, affecting your immune system negatively, and then that can make you more vulnerable to things like cancer. But we will talk about that a lot. We have a whole chapter on stress and well-being and health, and so we'll talk about that a lot. A lot of how stress impacts your body has to do with how you view the stress. Okay, and so there's one more term I'd like you to know, since we're talking about correlation. This isn't like a type of correlation in terms of like positive or negative, but it's just a term under the topic of correlation. So I wanted to talk about it now. And so it's called an illusory correlation. And this is when you think that there's a relationship between two things and actually no relationship exists. So we'll go through a couple examples. So the first one would be, let's see, this belief that when there's a full moon, people act sort of crazy, okay? So there's no evidence of this, okay? So people have have tried to find evidence of this. People have looked at, dates that there's a full moon and things like, police calls and how many people have come into like the ER and all kinds of things, accident rates and all sorts of things you can think of. And there's been no correlation. And so what happens is the reason why people believe it is that this idea got started, and then we only pay attention to when something confirms what we believe. Okay, so let's say you're driving around and like, people are cutting you off, and like the third or fourth or fifth person like cuts you off, and people are driving erratically, and you think, oh my goodness, and then you look up and you see it's a full moon, and you say, oh, it's a full moon. Like, that's what people are acting crazy, right? If the same thing happened to you, where people are, driving erratically and cutting you off and you looked up and it was not a full moon, you would not register that. That's not interesting, right? That's not interesting. So you wouldn't think to yourself, oh, this violates my full moon hypothesis. No, it would just go right out of your mind. Okay. You would just think like, oh, people are nuts, right? And move on to something else. Okay. So you only log the data in your brain when it confirms your full moon hypothesis. Okay. And so then the illusory correlation gets stronger and stronger. Okay. Okay. Another example. And so you're not going to like this one either. So this is the belief that sugar makes kids act hyper. So I know sugar is a real thing. So glucose gives you energy. Yes, 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 this is true. But the problem is they can feel it in their bodies sometimes, right, the sugar, but it actually isn't enough of an effect to change how they appear to other people. So here's what I mean. So they've done experiments where they give kids, snacks, and half of the kids randomly get, a cupcake, and half of the kids get some carrot sticks. Okay. And then they go play, and people who, independent observers who don't know what the kids ate rate them in terms of how hyper they are. And they're way off. So the observers have no idea who had the cupcake and who had the carrot sticks. Okay. Kids are just, the problem is kids are just hyper. Okay. And that's how they are. And so, especially when they're, at a birthday party, or they're, out playing with other kids, or they're just acting like kids. And so we blame sugar. Okay. But really kids are just acting like kids. So, okay. I'll give you one more. And so this is, I don't know if this is so much true here, but I grew up in Connecticut, and so we had a lot of, we had the 4 seasons for sure. We had, pretty long winters, and so members of my family who had arthritis, pretty much everyone had arthritis if they were old, and so they always thought that they could like predict the weather. So if you know this, if you've ever lived in a cold climate, or if you have like older relatives who have arthritis who think this, then you can relate. And so whenever they would have like joint pain, like arthritis joint pain, they would say like, oh, we're going to get a storm, right? And no, okay. No. So they've looked at, scientists have looked at this, and in fact, no, there's no relationship. So they've had people with arthritis, rate their arthritis pain every day, and all different aspects of their arthritis. And then they've also secretly, collected weather data, like barometric readings and all of this. And there's absolutely no relationship, okay, between arthritis pain and the weather. But, this didn't stop, certainly my relatives from believing that they could predict the weather. And so why is that? Because their elbow hurts, or whatever, or their knees or their whatever. And they look outside and it looks like it's getting overcast. It looks like we're going to get a storm. And then they say, oh, look. Right? I can predict the weather. It's just like the full moon and the sugar, and it's the same thing. Okay. Okay. So I want to just get back and show you where we are in terms of our our outline for talking about research methods. Okay, this is just a little recap. So this is what we're talking about, research methods. We've talked about all of this. We talked about descriptive research and all those three. We talked about correlation. So next we're going to talk about an experiment. I just want to take a little break. Okay, so this right, so this doesn't go over over an hour. Okay, and so the next lecture will be on this. Will be on the third research method. Okay, the experiment.